Hello viewers, today we are going to learn about Verilog basic and its modeling styles. Introduction to hardware description language with Verilog. What is Verilog? Verilog is the hardware description language. It does mean that what are the program we have written in the Verilog, it describes the hardware which is going to be implanted or which is going to be designed on the FPGA board. FPGA board is basically the blank circuit board which is given with special circuits like AND gate, OR gate, mux, demux, encoders, decoders, etc. And using the program, we can just going to connect all of them as per our need, and we can design any kind of digital circuit. It is used to model electronic circuit systems like digital circuits. It was originated in developed in 1980s. Now it is standardized as IEEE 1364. It is popular in FPGA and ASIC design. ASIC is the specific application specific integrated circuit or application specific integrated chip, which can be used when we have not going to change any kind of design inside the chip, as like the chips in the washing machine, the chip in your air conditioner, and etc. Applications of Verilog: designing digital circuits like registers, ALUs, CPUs, etc. Simulation and verification of logic circuits, FPGA programming, system on chip development. Verilog design flow. First, write the Verilog code. Either you can use the Xilinx software or you can use the EDA playground. Simulate using test benches. Test benches as the similar program which can be applied to the program to check whether our program runs well or not. Synthesize to gate level netlist. So make the design which is designed using number of gates. Implement on FPGA or send it to ASIC fabrication. So now the design is ready to be implemented on the blank board of the FPGA, or it can be fabricated on the ASIC board. Verilog structure. Verilog is built using different kinds of modules. Modules are basic building blocks of the Verilog design. It defines the ports like input, output, and in-out. In-out is the kind of wire which is there between input and output. Data types allowed are wire, range, integer, etc. Operators allowed are arithmetic, logical, bitwise, etc. For example, module AND gate. Here AND underscore gate is the name of the module. It can be variable. You can take as per your need. In bracket, the ports are defined which has input A, input B, and output Y. As we are going to design simple AND gate in this module, I will use the data flow style of modeling, which is assign y is equals to a and b, and then we will use the primitive AND module. If you are not aware about what is data flow kind of modeling, don't worry, we are going to see them soon. Verilog modeling styles. It may be the gate level modeling, second data flow modeling, behavioral modeling, or it can be structural modeling. Gate level modeling describes the circuit using basic logic gates. It uses predefined primitives like A and D and or not, etc. For example, here I have used AND gate primitive, which is A and D. In bracket, first the output will be defined, which is the Y of my gate, and then two inputs A and B. Pros: it is close to hardware. What we are going to implement on the design, that will be implemented on the hardware. Cons: tedious for the large design when it is the case of ALUs and different modules counters at that time. Using the different types of gate, design becomes more complex and becomes very large. Behavioral style of modeling describes what the system does. It uses always blocks and procedural code. As we will see that a Verilog system, Verilog design is the concurrent style of modeling. That means all the lines will be executed at the same time. But if we want the system code to run step by step or the line by line, at that time it is necessary to use the always or initial block. So here in behavioral style of modeling, we are going to always use the always or initial block. As initial block is non-synthesizable, it is only used in the test bench. It will not be used in the program itself. Behavioral style of modeling just describes the behavior of the output of the system. Here, the bitwise operator AND is written over here. What does it mean? That it will give me the output of A and B. Now, the AND gate can be designed in any ways. It can be designed using the mux or anything else. So, we are not interested in whatever the physical structure of the design, but what it behaves like. Pros: high level of abstractions, and cons: less control over physical structure. Structural modeling. It connects different modules to form hierarchy. It is similar to building block diagrams. For example, here I have used number of AND gates. We can use number of AND gates, whatever the module we have used, which is AND underscore gate. Now I can give the another name to it. It is like U1, and I can use it multiple times on my software. In the gate level modeling, it is not the use. It is only uses different types of gates, but here the reuse of the same structure can be used, which is known as structural style of modeling. Pros: represents real hardware structure. Cons: complex for large system. Test benches. They are special modules used to simulate and verify the functionality. No input and no output ports, just we are going to instantiate our input of the test bench and the output of the test bench to the input of the program and the output of the program. It uses the initial and always block. Test benches are non-synthesizable codes which cannot be implemented on the hardware. They are just used to verify the system, verify the code we have written in the Verilog. For example, if I'm going to check out what my output of the AND gate will be there. So I'm going to use the initial statement and I will use the keyword which is begin. I will initialize my A as 0 and B as 1, and this value will be applied to my design and it will give me the output Y, whatever that may be. After 10 units of time, my input will change to A is equals to 1 and B is equals to 0, and accordingly my Y will be changed. And hence, actually when we are going to implement it, we are not going to give the test benches to the hardware. At that time, we will have to give the inputs through the pins. Summary. Verilog. It is hardware description language for modeling hardware. They have 4 modeling styles: gate level, data flow, behavioral, and structural. Choose the style based on abstraction level and design needs. If you have any question, please do not hesitate to post on the comments. Thank you.